Hi guys, it's Mrs. Russell, and I wanted to talk to you a little bit more about isostasy. This is a concept that we introduced in class today, but I did want to create a video talking about it in a little bit more detail. Isostasy explains how the lithosphere is floating on top of the asthenosphere and what those two layers look like whenever you were to put them in a picture. So I'd like to explain this concept by first using an example of a boat in water. If I drew my boat in the water, you would see that the boat is floating in the water. That is because the boat is less dense than the water. The boat is less dense and the water is more dense. Let's pretend I added 3 tons to my small boat. What's going to happen? Well, it's not going to sink all the way, but it definitely is going to dip down further into the water than it did before. So with less mass, it's less dense. With more mass, it's more dense. It's still less dense overall compared to the water because the boat is still floating, but it does dig deeper into the water. Well, what if I took that mass away? Let's say I took 2 tons back. Well, as you can imagine, the boat is going to pop up out of the water a lot more than when it had the 3 tons. Because I just took some of its mass away, making it less dense. Again, all 3 boats are still less dense than water. How do I know? Well, because all 3 of them are floating. But this boat right here, the middle boat, is the most dense out of the 3 boats. Well, how do I know that? Because it's dipping the deepest in the water. So you're probably thinking, Miss Russell, how are boats relating to the layers of the earth? Well, we talked about the layers of the earth, in specifics, the crust and the mantle. We learned that the crust is the outermost region and the mantle comes second. The crust is the layer that refers back to my example of the boat, because the crust is floating on top of the mantle. And the areas where we had more mass and our boat actually was digging deeper down into the water, that's areas on Earth where we have landforms that have more mass. Thus, they have more density and they dip deeper into the mantle of the Earth. So as you can see here, some continents. And on the continents, we have landforms. This looks like a mountain range. The mountain range has more mass, more density, and so it dips deeper into the mantle. Does it actually go past the mantle? No, because the mantle overall is still more dense than the crust. So the crust has different amounts of density, but it still overall is less dense than the mantle, so the crust is going to float. And if we get into even more details, we learned this term lithosphere. Lithosphere is a fast way to refer to both my crust layer and the top of the mantle. So as you can see in this picture, here's the crust, my oceanic right here, and here's some continental crust, and then back to my oceanic. Well, looking at my crust layer, this is not a perfectly straight line because underneath this mountain of continental crust, I have more density and more mass, and so this region is going to dip deeper in the asthenosphere. Isostasy explains how the lithosphere is floating upon the asthenosphere. There are regions of the lithosphere that have more density, for example, mountain ranges, that dip lower into the asthenosphere, but even so, they are still less dense than the asthenosphere, so they float.